Hello, we're going to be working with the unit circle still, but in this case we're going to be finding exact values of angles in the unit circle. So if you could see here, I don't know if you were able to print it out or not, but we're going to be using the unit circle a lot. And so hopefully you can have that handy somehow for you. But before we get to the unit circle, I want to take you here to here is a triangle within the unit circle. And if you remember when we were dealing with sine, cosine, and tangent, if you were to take that triangle with the radius 1, because it's a unit circle, this value here is your x value, and then the vertical value is your y value, or the vertical amount. If you were to find, let's say, theta here, you want to find an angle of that. So let's say I want to find the sine of theta. So I'm going to write sine of theta. Remember, sine of an angle is opposite over adjacent. So sine of theta is y over 1. And y over 1 is just equal to y. So when you're talking about sine values, you're really talking about the y value. And you'll see what that means in a bit. But let's say we want to find the cosine of theta. Cosine of theta. Well, cosine would be adjacent x over 1. So it's going to be x over 1, which is just equal to x. So in the unit circle, the x value has to do with the cosine values. And if you want to do tangent of theta, well, tangent is opposite over adjacent. So it's going to be y over x in this case. Well, if it's y over x, then it really is just sine over cosine. So we know that tangent is equal to sine over cosine. So we're going to be dealing with these three identities, we call them trigonometry identities, in the unit circle here. So to find exact values of angles, let's go up here. Let's start with number 1. We want to find the exact value of sine of 225 degrees. So we go to our unit circle over here, and I'm going to go 225 degrees from the standard position. So I'm starting here, and then I'm going to go to 225 degrees. So this is the angle where I'm at. And if I'm looking for the sine value, remember up here we said the sine value is just your y value. So we go to here, 225. Sine of 225 would be the y value, which is negative radical 2 over 2. So your answer would be negative radical 2 over 2. That is the exact value of sine of 225. And if you want to, you can plug that in your calculator. You can type in sine of 225, and it gives you negative 0.0707. Now I'm going to do radical 2 divided by 2, negative radical 2. So I'm going to do negative radical 2 divided by 2 equals negative 0.07. So this is the decimal value, but in today's lesson, we're just going to be dealing with the exact value of these angles, all right? So here we go. Now let's find sine of negative 810 degrees. So sine of negative 810 degrees would be, let's start here, negative 810 degrees. So let's see, and I'm going to go one full circle. That's 360. And if I do another 360 and 360, that's 720. 720. So I need to go to 810 degrees. 720, that means 90 degrees more. So here I am. This is my position. And I want to find the sine value of that. And remember, sine value is your y value. So it's going to be equal to -1. So this is -1. Okay, now cosine of 30. Cosine of 30 would be, well, that's easy. That's going to be right here, 30 degrees. And cosine of that would be, cosine was the x value, radical 3 over 2. Now we need to find sine of 600 degrees, negative. So it's in the negative direction. 360. If I do another 360, that's too big, 720. So I need to go, how about 90 more? 360 and 90 is 450. Another 90 degrees is going to be 540. And let me see, 360, 90 is 450, and 90 is 540. It's okay to take out a calculator, 540. So I need to go to 600. That's 60 degrees more. So that's going to be here. So I'm at 120. I'm in the position of 120 degrees positive, really. But all I care about is the position, and I'm looking for the sine of that. So the sine is the y value, radical 3 over 2. Okay, now I need to find the cosine of -150. Cosine of -150 would be 30 degrees short of 180 in the negative direction. So the cosine at this position would be the x value, negative radical 3 over 2. And then lastly, tangent of 30 degrees. Tangent of 30 degrees would be right here. But tangent, remember we said tangent is sine over cosine, or y over x. So what we have to do over here is we got to do y 1/2 over x, radical 3 over 2. And so divide these fractions, you need to take the reciprocal of the second one, and then it becomes a multiplication problem. The 2's cancel out. You're going to get with 1 over radical 3. And 2, we need to rationalize this fraction, meaning we don't want to square root in the bottom, so we need to multiply by square root of 3 over square root of 3. That's going to give us square root of 3 on the top. Square root of 3 times square root of 3 is square root of 9, and that becomes just 3. So your answer is going to be square root of 3 divided by 3. So that's how you find the exact values of trig functions given a certain angle. You can use your unit circle here. Okay, now we're going to move to finding exact values of trig functions given to us in radians, where the angle is in radians. So the first one here, we have cosine of 2 pi thirds. And what I've done here is I'm going to look at that bottom number, pi thirds. And so here's a circle that I have, unit circle, where I've already cut up the circle into pi thirds. Remember, 0 to pi. And I have that cut, wrong piece here. Here's my pi thirds, 0 to pi. That means I have I've cut pi into 3 pieces. That would make it a total of 6 pieces for the whole unit circle. So if I want to find 2 pi thirds, that means I need to go 1, 2. So this is the position that I'm going to need to find the cosine value of that. So that position would be 120 degrees up here. And then the cosine value would be the x value, so it would be negative 1/2. Negative 1/2. The second, number 8, would be 11 pi over 4th. So I need to find my unit circle where I'm dividing pi into 4 slices. 11 pi over 4, that means I'm going to go 11 slices over. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is a position that I'm in at that angle, 11 pi over 4th. If I go up here, 11 pi over 4th would be about there. And I'm looking at cosine of that, so it would be x value, negative radical 2 over 2. 7 pi over 6 would be the next one. So I need to come out with the unit circle where it's sliced up into 1, 2, 3, 4, 5, 6 slices. The top half 6. So 7 pi over 6 would be, let's see, 6 slices, 7 slices, which would be here, which would be at 210 degrees up here. And I'm looking at sine, which is the y value, negative 1/2. Cosine of 19 pi 6, I'm already here at pi 6, so I need to find 19 pi 6 slices. So I know that one full circle is going to give me 12 slices. I need 19. 12 and 6 more, it's 18, 19. So I'm back in this position again at 210 degrees. But this time I'm looking for cosine of 19 pi over 6. The cosine value here would be the x value at 210 degrees. The x value would be negative radical 3 over 2. And then lastly, 10 pi thirds. Tangent of 10 pi thirds. Let me bring out my 10 pi thirds. Here we go. 10 pi thirds tangent, and it's positive. So it's going to be 6, 7, 8, 9, 10. That's going to be at 240 degrees right here. And tangent is y over x. So it's going to be negative radical 3 over 2 over negative 1/2. They're both negative, so that's going to cancel out. If we take the reciprocal of the bottom fraction, those reduce. So my answer is going to be positive radical 3 over 1, which is just radical 3. Okay, so that's how you find the exact values of trig values using your unit circle.